In this lecture, we will talk about custom data types. First, we will talk about structures. Structure is objects that has multiple fields inside, and to define structure, we use the keyword struct. Then we have the structure name, and inside we have the fields. So here we have this point structure that has x and y inside. So now to instantiate this structure. So yeah, to create object from this structure, you use the name of the structure, and then inside the curly braces, you must initialize all the fields that this structure has. So for example, if you leave some of them, Rust will complain. So yeah, so you also. And again, when you have this object, to use these fields, you use the dot operator. So here is how you do, yeah, just dot operator, and here we can print just to see the results. And these fields can be initialized in multiple ways. So I will show couple of ways here. So for example, if we have some other variable, then of course that we can do something like this, and that's clear. But if this variable have the same name as the fields inside the structure, then this column part is optional then. So for example, if we rename this variable to be x, we can remove this part of the column and put just like this. Okay. Also, if you have, for example, some other structure and objects, we can copy fields from the other structure to this new structure using dot dot operator. So for example, we can do something like this. And now this structure will have all the same fields as the above structure. And we can see this. Also, you can copy just the part of the above class. So here we can also do manually some of the fields. And rest of the fields will be copied from some other object. Like this. You can destructure the structure into basic variables, and this is how you do it. So it's similar as when you define the structure, just you here must put the variables that will hold the fields, and we can print just to verify here. Also, using the structure, you can define something like a named tuple. So here we can define named tuple. See this simple vector that has 3 components inside. And yeah, and now to, for example, to instantiate this vector, it's very similar as for the tuples, just that we have the name. So yeah, so we just put the name, and also in this parenthesis, inside parentheses, we just initialize the fields. And to access these fields, we use also the dot operator, but here we also must put the index of the elements inside the tuple. So it's very similar as for the tuples, it just has the name. Also, we can also destructure this named tuple, also as for tuples. So yeah, you just here define tuple, and you just define variables that will hold these fields. And now we can just print to see that it's working. I just forget here semicolon here. And we see these results. Next, we will talk about enums. Enums is type which may be one of the few different variants. So first I will just delete all these. To define enum, you use the enum keyword. So here we define the color enum that has 3 variants inside. Now if you want to instantiate this enum, you just specify the enum name and then use double column operator and select one of the variants, like this. And now if you want to check which variant is active, you can use the match expression. Okay, I'll show you. So here, as I said, we have the match keyword, then we have this enum, and inside the curly braces we have the matching arms. So here we have 3 matching arm. On the left side of each arm you have the pattern, and if this pattern is satisfied, then this expression on the right side is executed. Also, this match is exhaustive. That means that you must cover all the variants that enum has. So for example, if you comment out some of the variant, Rust will complain that we didn't cover all the variants. Okay, look at this. We can now run this. To verify, we see message color is red. As you write, you can write some other just to check. Okay. Yeah, we see color is yellow. Also, with this match, you can write these patterns in many different ways. So this match statement will be covered in separate lecture. One of big advantages of Enum is that it doesn't need to follow just the simple variants as shown here. It can hold the variant that also has data. So here we'll add some tuple that will hold the color. So basically any data type can be specified inside the enums. Also now Rust complained that we didn't cover all the matching arms. So we will add new matching arm. On the left side we see this pattern matching, and basically it's very similar as you destructure the tuple. So this C1 tuple is destructured into some local variables, then can be used in expression on the right side. And to instantiate it, we just need just the name of the tuple and values inside. And you can run this. So this was just a short introduction into structure and enums. From now on they will be used almost in every lecture. See you in next lecture. Bye.